Hey everybody, we are ready to start chapter 6. First section is on the fundamental property of rational expressions. So we'll start to talk about what a rational expression is, and we'll do a few simple things with them in this section. So first of all, a rational expression is the quotient of two polynomials. So the quotient of two polynomials with denominator not zero is called a rational expression. Alright, so I'll give you some examples. So a polynomial could be something like x plus 5, right? That's a polynomial. It's a binomial in this case. And so we put that over another polynomial, like maybe 2x squared minus 3. So that is a polynomial over a polynomial, which would make this a rational expression. As long as the denominator is not 0, we're okay. Let's give you another example. So that's one example of a rational expression. So we could have larger polynomials here. We have a binomial over a binomial. We could have something like 3x cubed minus 4x squared plus 5x minus 9. So that is a 4-term polynomial. We could put that over another polynomial. Maybe something like x squared minus 3x plus 2. So this big nasty thing is also a rational expression. We have a polynomial over a polynomial. So you might wonder about other things that could happen. So if we have something like just x plus 4, you could say, is that a rational expression? You might be tempted to say no because it's not over another polynomial, but we could always write it over 1. 1 itself, any number, is a polynomial. Even though it's only one term, we still consider those single numbers or single variables in the family of polynomials. So any of these things could be polynomials. Any whole number is also a polynomial, just a special polynomial. So rational expressions, a lot of times we want to what we call, reduce them or write them in lowest terms. So just like with a fraction, I'll give you an example here. If we have a fraction like 6/12, so 6/12 is a fraction, right? If we want to write it in lowest terms, we take out the greatest common factor of both of them, right? In this case it's 6. We divide both top and bottom by 6, and we get 1/2. So 6/12 written in lowest terms is 1/2. So a rational expression is written in what we call lowest terms if the greatest common factor of its numerator and denominator is 1. So once we reduce to 1/2, the greatest common factor of 1 and 2 would be 1, right? Now we could also do this with polynomials, and we'll actually have some practice with that a little bit later on in this section. So we'll get there. So the next objective, the first objective, I guess, find numerical values of rational expressions. This should be the easiest part of this section, probably this chapter. These are plug and chug problems, right? We're asked to find the numerical value of this rational expression if x is -1 and then if x is 4. So we just plug in -1 for x and then simplify, right? So let's do that. 2 times -1 minus 5 over 2 minus -1 minus a -1 squared. Alright, so I plug -1 everywhere. Notice I put the -1 in parentheses, that way I don't have any issues. If you don't, with negatives, sometimes you have some problems. So anyway, let's simplify the top and bottom separately, and then we'll try to see if anything can be reduced. 2 times -1 is -2. Minus 5 would give us -7, right? And you could plug that into a calculator if you weren't sure. 2 times -1 minus 5 should be -7. On the bottom, I'm going to do a little bit of simplifying because there's a lot of negatives here. Minus a negative is really a plus, right? So this would be 2 plus 1. Now we can't do that here. We can't do minus the negative and change it to a plus, because order of operations tell us we have to do the exponent first, right? So we actually have to square the negative 1, which is positive 1, and then we subtract it. So this would be minus 1. That might be a little confusing, but it's all about order of operations. We do exponents first, right? So we got to square the negative 1 first, which is a positive 1, and then we're subtracting the positive 1. So let's see, what do we get? 2 plus 1 is 3, minus 1 is 2, right? Yeah. So we get negative 7 halves, and 7 and 2 don't have any common factors other than 1, so the greatest common factor is 1, and we're okay there. Now some people may ask, well, where does this negative go? Well, the negative seems to be with the 7, right? So we have negative 7 over 2. Well, that's a negative number. The negative could actually go with the 2 also. This is the same as 7 over negative 2, right? It's still a negative number. And some people prefer to put the negative sign out in front of the fraction bar, so you could write it as negative 7 halves. So the whole number is negative. So all three of these are actually the same number. What you don't want to do is put a negative with both and think it's the same, because if I had a negative with the 7 and a negative with the 2, then the negatives would actually cancel out and it would be a positive number. So the negative can go either with the numerator, denominator, out in front of the fraction bar, but don't put the negative with both of them unless it's a positive number, and then you wouldn't write a negative with both anyway. So I'm just going to leave it as this one, but these two would be fine as well. Alright, 4, that's a positive number. It might be a little easier, I don't know. So on the top we have 2 times 4 minus 5. On the bottom we have 2 minus 4 squared. Alright, so on the top, 2 times 4 is 8, minus 5 is 3, right? On the bottom, 2 minus 4 is a negative 2. And here we don't have that issue with the negative, so we have minus 4 squared is 16, right? We do have to do the power before we subtract the 4. But now we have negative 2 minus 16 is negative 18. Is that in lowest terms? Hopefully you say, no, it's not, right? Because 3 will go into both of those. 3 goes into 3 once and into 18 6 times. So I have 1 over negative 6. Again, this is a negative number. I could write it as negative 1 over 6, 1 over negative 6, or negative 1/6. Any of those would be okay. I'm just going to leave that one. But again, negative 1 over 6 would be the same. And negative in front of the fraction bar. All three of those answers would be equivalent. What you don't want to do, again, if it's a negative, is put a negative with both, because that would mean it's a positive. Unless it were a positive, then you could do that. Alright, so let's look at objective 2. Find values of the variable for which a rational expression is undefined. So, when are these things undefined? Let's try to figure that out. Well, if we go back up above, remember, we have problems when the denominator is 0. So we want to make sure the denominator is not 0. In fact, that's how we're going to tell when the denominator, or when this expression is undefined. To figure out when the expression is undefined, we are going to set the denominator equal to 0, because that would cause us to divide by 0, and hopefully back in the day you learned at some point in your life that dividing by 0 is not possible, right? So 7y minus 1 cannot be 0. Now the numerator can be 0, but 7y minus 1, which is the denominator, cannot be 0. So let's set it equal to 0 and find out when this expression is undefined. So here we would add the 1, right? So we have 7y equals 1. Then we divide by 7, right? And so y equals 1/7. So find any values of the variable for which the rational expression is undefined. It's undefined when y equals 1/7. All right. That's the only time that one's undefined. Now, next one. We have a quadratic here on the bottom. We have 3 terms, right? So let's see, we have a trinomial. Let's set it equal to 0. Again, the numerator can be 0. The numerator we don't even care about with these particular problems. So m squared minus m minus 20. Right? We want to set that equal to 0 because that will tell us when the expression is undefined, when we would have to divide by 0, which is really not possible. So if you remember, not long ago in chapter 5, we solved equations like this using factoring, right? And so we asked, can we factor this polynomial here? And hopefully you remember how to factor a trinomial, especially if the leading coefficient is 1. This is not hard to do, right? We can factor it into two binomials most likely. We'll try anyway. We need two factors of negative 20 that add up to negative 1. We'll have an m and an m, right? And so two factors of negative 20 that add up to negative 1. We could probably use 4 and 5 somehow, right? And since this middle term's negative, the bigger one has to be negative, so minus 5 plus 4 I think will work. And you could always check by foiling, right? M times m is m squared. Negative 5m plus 4m gives us a negative m, and negative 5 times 4 is negative 20. So now that we have two factors set equal to 0, we just need to see what would make each factor 0, right? So 5 would make this factor 0. Everybody agree? Hopefully. So m equals 5 would cause this to be 0, and 0 times anything is 0. If we put in a negative 4 here, that would cause this factor to be 0. m equals negative 4. So we actually have two places where this rational expression is undefined. M equals 5 and m equals 4, negative 4. Now I'm not sure on my lab, but you may check. They may ask you to write this as a set of numbers, so you might have something like this, 5 comma negative 4. But I'm not sure. Yeah, so you check my lab, see how they want your answer presented. They may give you the set symbols and ask you to put it in that way. But those are the two places where the denominator is 0, which makes the expression itself undefined. Alright, so we have this last one. X squared plus 100 equals 0. Well, we haven't been able to factor something like this, have we? This is a sum of squares, and if you remember, you cannot factor a sum of squares. And if you think about the solution, so if you try to solve this any other way, let's say we subtract 100. We get x squared equals negative 100. Is that solvable? Is it possible? Well, is there any real number you can square to get a negative? And you cannot, right? You can't square a number and get a negative. When you square a number, it's either positive or it could be 0 if you square 0. But so this is not possible. There's no solutions, and that means this expression is always defined, right? It's not possible for the denominator to be 0. So this is not possible, which means, or I guess I should say there are no real numbers, right, that would work. If you know things about the letter I, you could solve this, but it would be for imaginary numbers, not real numbers. So what I could say, since this equation is not possible to solve, we could say this is defined for all real numbers. And that's how I would state my answer. It's defined for all real numbers. Alright, so that's it for this page. I'm going to stop this video and we'll go on, continue on the next video.